Hi everyone, my name is Tarun Awala, and this is my Lab 2 for Physics Lines of Charge. So, the goal of this lab is to compare the electric force predicted by the point charge model, which was used for the floating tape in Lab 1, with the force predicted by lines of charges in this model. So, in the lines of charge, the tape is divided into several small sections, with each section treated as an individual point charge. And there was also a glow script code generated which was a computational simulation used to model the tape and calculate the forces between the charges. And the results? The point charge model from the last lab indicated a total charge of 1.184 times 10 to the negative 8 coulombs, while the lines of charges model yielded a result of 2.585 times 10 to the negative 8 coulombs. So some of the fundamental ideas that we utilized in this lab were Newton's second law, which is equal to F net equals to the change in momentum over change in time, and it basically states that a system's momentum changes in direct response to the total force acting on it. And then gravitational force describes the force of attraction that exists between any two objects with mass, and its equation is negative g times m1 times m2 over r squared times r hat. And then Coulomb's law was also integral, which explains how electric charges either attract or repel one another, and its equation is k q1 times q2 over r squared times r hat. So just to reiterate some of the initial conditions from lab one, the mass of the tape was 2.02 times 10 to the negative 4. The length was 0.22 meters, the width was 0.02 meters, and the area of the tape was 0.0044 meters squared. And these were some of the calculations that took place in the previous lab. And the ones we really need are just the gravitational force and the electric force. And we can also use calculus now to calculate the electric charge on tape B by integrating the entire distance of the tape. And in this equation, R is the distance between the tapes and L is the length of the actual tape. And this yielded a result of 2.585 times 10 to the negative 8 coulombs after integration. So for this computational model, I first defined the main physical constants like Coulomb's constant and then gravity. And then I input the measured values from the experiment, including the mass of the tape, total charge, length, and the distance between the two tapes. And then in this part of the code, I model each tape as a line of charge instead of a single point. And it does this by breaking each tape into many small pieces spread along its length. Essentially, this makes the model more realistic because charge is actually distributed and not concentrated at a singular spot, like we assumed in last lab. And after building the two tapes, the program essentially calculates the total electric force on the top tape caused by the bottom tape. And finally, it compares the electric force to the gravitational force so we can properly see how they relate physically. And on the right side, you can see the model where the green arrows basically indicates uh, the electric force at each singular point, not just like a point charge, like we thought in the last lab. So some of the errors and assumptions that were present in this lab our main assumptions were that air resistance and frictions are small enough to be ignored, and each piece of tape is assumed to carry the same total charge spread uniformly across its surface. And we learned that some of the assumptions were not correct, and some of the errors included that the measurements taken during the experiment may not have been precise, and also some charge may have been lost due to handling or interactions with the surrounding environment. So let's talk about some discussion questions now. The first one is how would the results vary if the tape was considered a point charge? And as you can see, the line of charge is greater than the point charge, and the point charge was 1.184 times 10 to the negative 8 coulombs, while the line of charge was 2.585 times 10 to the negative 8. So why do the charge estimates differ from the actual value? The two estimates are different because they're calculated using different levels of approximation, precision, and detail. So the line charge model is more accurate since it accounts for charge distributed continuously along the length of the tape rather than simplifying the entire charge as if it were concentrated at a single point. Thank you for listening.